All right, guys, here we go. Time to dive into Math 8, and we're going to do this in a way like what I've done before, but hopefully better. Okay, so we're going to learn together as we use dun, 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 the textbook. I know you're probably like, Ms. Field, I know you've used the textbook before, but usually for my videos, we do online work like IXL or Khan Academy. So you can see some parts of the textbook we will do specifically in class. Some parts of the textbook we will do now and then review in class and annotate. So are you ready? We'll do that in class so I can watch you do your math. The Spark Your Learning, we'll do that in class. But let's look at our different examples. So we have 1, A, B, 2, 3. All these these examples are how you learn. Okay, so we need to make sure that you all have it in your notebook. So we have a textbook, but you can see there's not a lot of extra space. So we're going to keep a good notebook and let's get started. Okay, so whatever you see me write down in this notebook, you also have to have, it doesn't have to be green, but other than that, it should be the same, okay? So we're going to write Math 8 at the top. We're going to write the date. So you always, when you take notes, you put your class, you put the date. Of course, you can put your name, right? I guess you generally put your name up there. We'll just put it over here. All right, there we go. And then right here, the title, notice the title, I didn't put math or whatever, notes. Some people title their notes, notes. We titled it Module 10, Real Numbers. And let's see why. Because, oh, you know what? This is the reason I titled it Module 10, Real Numbers. But now that I'm looking at these notes, I'm going to put one extra part of my title. I'm going to put Lesson 1, Understand Rational and Irrational Numbers. Now, notice how I said it and I am writing it. That is because I do understand that my writing is not very good. Okay, but you can see it, right? Lesson 1, Understand Rational and Irrational Numbers. Okay, now we're going to go to the next page. And the next thing we're going to put in our notes is the vocabulary. So you can see we have 1, 2, 3, 4 vocabulary terms. So I am going to take time, and you don't have to watch me because I'm going to pause the video. But when you after I unpause the video, I'm going to have all 4 of these terms and their definitions written in my notes. 1 second. All right. Whew, my hand hurts from all that writing, but now you can see, and you can go ahead and just autofocus it here. So you can pause this, and you can write this as well, because we're all right. We all do this. Rational number. Any number that can be written as a ratio in the form A over B, where A and B are integers and B is not 0. Okay, so that means you can write it as a fraction. A over B, this is a fraction. Now, you can also write rational numbers as decimals, and there's 2 kinds of decimals. So notice when I did the rational number, I put a closed dot there, and now I'm indenting and I'm writing the 2 different types of rational numbers, terminating in their decimal form. Terminating decimals, that's a decimal that has an ending, and repeating decimals, a decimal that has no end but has a repeating pattern. So if a number is not rational, it is irrational. that's a number that cannot be written in the form A over B. So you cannot write this number as a fraction. That means you can only write it as a decimal and not even that, because irrational numbers actually don't have an end. So we can only write their approximation. All right, so where A and B are integers and B is not 0. All right, sorry about the little grease stains there. Mr. Field didn't wash his hands after lunch. Okay, sorry. So rational examples. Let's look in the book and we see 3 over 8 is equal to 0.375. Let's write that in our rational circle. 3 over 8, definitely a rational number because it's a fraction, and it equals 0.375. And let's just draw an arrow to that. What kind of decimal is that? That's a terminating decimal. So we'll write terminating. Okay, now let's see if we can find a repeating decimal out of the, oh, there's another good one. 7 is 7 over 1. That's why that's a rational number. 0.2 is equal to 1/5. So see, you could start out with a fraction and find out its decimal, or you'll learn to start out with a decimal and find out its fraction. So they're two equal ways of writing the same quantity, right? And this one right here, 1/9 is a fraction, so put it in the rational circle, but it has a decimal that goes on forever. 1, 1, 1, 1, 1, all these ones. And they never stop. So we put a dot, dot, dot. Or you could put 0.1 with a bar over it. Both of those mean that it's not going to stop. Now, irrational numbers, pi is your first one. You should know about pi. It's 3.14159, 26535897932, and it goes on forever. Talk more about pi when we talk about circles. And it's not exactly 3.14, so we put the wavy lines, but its first three numbers are 3.14. So that's an approximation. And I'm going to put one other example, even though I don't see it in the book. I know it as a math teacher. The square root of 2 is an irrational number, and so is the square root of 3. And you might say, what about the square root of 4? But actually, the square root of 4 is rational. Why? Because it's 2. So these ones are decimals that are irrational. If you put them in the calculator, you'll see that. All right, let's move on. I can just talk all day about these things. So now let's go. Like I said, we're going to do the 4 examples. And I have a time stop, so that's good for you and me. So if we don't get through all 4, we'll get through what we can. Is every number rational? Well, we already know the answer is no. Consider the decimal 1.3453, blah, blah, blah. Does this decimal appear to have a repeating pattern? Okay, instead of saying blah, 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 let's look a little closer. 3, 4, 5, 3, 4, 5, 6, 3, 4, 5, 6, 7. Well, it did have 3, 4, 5, and then 3, 4, 5 again. But then I would say no. Oh my goodness. What am I doing? Writing in the textbook. Okay. So 0. So we're going to write, when we do the textbook examples, I'm going to draw a little line indicating I'm done with my vocabulary. And we're going to write example 1. And then we're going to copy down the number. So 1.345, 345, 634, 567. Okay. And the question is this rational? And the answer is no. There is not a repeating pattern. There's not a repeating pattern. It only repeats twice. When we say repeating pattern, we mean repeats over and over again. So that's a no. But now, do you think, oh, it's rational? So yeah, so we just answered both questions. And that was A. And now we see B here. You learned that pi is the ratio of the circumference of any circle to its diameter. The decimal value of pi is shown below. Pi is an irrational number, but it can be written as a ratio. How could this be? Well, that's a good question, isn't it? So whenever we try to write, so what they're saying is a good question. So let's talk about, whoa, no, somebody, okay, let's talk about pi. And so here we are, pi. We know if we have a circle, all the way around the circle is called the circumference. And the diameter of the circle is all the way across the circle. Okay, and so pi is equal to the circumference C divided by D. But we cannot actually get the exact data. We can't actually measure the exact circumference and diameter, because if we did, then we would have a ratio. And so what we find is every time we try, it ends up being an irrational number. So the closer you get to the actual circumference and diameter, the closer you get to pi. It's a very interesting situation. So we could just say either C or D must be approximate, meaning you didn't actually measure the thing exactly. Okay, now let's keep going. There are two ways to write repeating decimals. You can use an ellipsis or you can use the overbar. So we talked about that. So let's just turn the page in our notes and we'll just make a section just for that here. We're going to get used to this here. All right, so right here, there's so much to put. So I'm going to take and I'm going to write ellipsis. How do you spell that again? Ellipsis overbar. Okay, so we got 0.111 dot dot dot. We could do that, or 0.1 with a bar. We could write 0.235 dot dot dot, or 0.235. Like that. And we could write, let's just do one more, 0.24444 dot dot dot, or 0.24, and just the overbar is over the 4. Okay, so we don't have to have the whole thing repeating for it to be rational, but it has to end up repeating forever. If you remember the first example, we only had the pattern repeat twice and then it stopped repeating. In this one, it doesn't start repeating, but it ends up repeating forever. And that's okay. All right, guys, we're doing good. We got about 5 more minutes. And so let's look at step it out. Okay. A basketball player's free throw percentage is 82.5% or 0.825. Write this as a fraction. And so you see they gave us some boxes to fill in, and They also gave us some vocabulary, but we should know that vocabulary. Okay, so let's draw our line and we'll write EX2. And then I'm gonna write 0.825 equals 825 over, whoops, there we go. And do you know what it's over? Well, this is a terminating decimal. So I'm gonna indicate that. And so anytime it's a terminating decimal, you look at the place where it terminates. And what place value is that 5 in? That is in the thousandths. So we're gonna put it over 1,000.
Oh, I thought you were gonna be the use copies yourself.
All right, did they give us any other examples? So now, now here, what are they doing here? Well, we have equal, division. It says, write the fraction in lowest terms, identify the greatest common factor, GCF, of the numerator and denominator, divide the numerator and denominator by the GCF. So you know what we got to do. We got to reduce this fraction, right? So 825 and 1,000, what is the GCF of both those numbers? You may or you may not know. If you ever need to figure out what to divide a number by, you can always start with 2. Like 1, 2, 3, 4, 5. Can we divide this by 2? The answer is, well, 1,000 you can divide by 2. That's 500. But this number, no. So then you could try 3. And I don't think you'll have a lot of luck because that 5 there. And then you could try 4. But maybe you already knew 5 is a good one. And if you know the GCF, you know, maybe we can divide them both by 25. Then you could do that. But if you can't figure out the GCF, you can always just start low and then divide again. So let's do 825 divided by 5 is 165. And 1,000 divided by 5 is 200. And you should notice, I think that I can divide both of these by 5 again. Because of that one ends in 5 and that one ends in 0. So 165 divided by 5 is 33. And 200 divided by 5 is 40. And now we have our reduced fraction, 33 over 40. So 0.825 is 33 over 40. And guess what? You can check. If you do 33 divided by 40 on the calculator, you should get 0.825 if our math is correct. Look at that. Look at that. Boom, boom, boom. I did it. Okay. So happy. All right. Now we're going to do example 3, and we're going to call it a day. We'll have to do example 4 in class. So example 3 is converting a repeating decimal to a fraction. And this is an important one. So let's read it and then we'll write it in our notes. Write 0.5 repeating as a fraction. Let x be the given decimal. Write the first few digits, first few repeating digits. Multiply both sides of the equation by 10 so that the repeating digit appears to the left of the decimal point. And it's just the repeating part. Subtract an expression equal to x from both sides. Solve for x. All right, let's do it. So this is an important one. This is example 3. So we're going to write example 3. And our first one is 0.5. We want to write this as a fraction. So now we're going from a repeating decimal to a fraction. So what we do is we say, we don't know what the fraction is, so we call it x. Okay? And now we need to multiply this number, both sides of this equation by 10. And then that will give us x times 10 is x times 10 is 10x. And 0.5 repeating times 10 is going to be 5.5 repeating. Because you take that decimal and you move it over to the right one. This 0.5 repeating is really 0.5555. So if we multiply it by 10, we're moving the decimal point over 1, and then we get that 5.555, so, or 5.5 repeating. So now I have two equations, this one and this one. And what the book is saying is I can take 10x equal to 5.5 repeating, and I can subtract from it that first equation, x equal to 0.5 repeating. And what happens when I do that? First of all, 10x minus x is not 10, because this is actually 1x. 10x minus 1x is 9x. And 5.5 repeating minus 0.5 repeating is 5. And now I have a one-step equation. So I'm going to divide both sides by 9. And x equals 5/9. And again, I'm just going to prove to you that it's true. 5 divided by 9 is 0.5 repeating. Pretty cool, right? And of course, we don't have to use a calculator to check our words. I could do the long division. 9 into 5. But I'm not going to do that right now. I'm just saying you could. All right. 2 pages of notes, pretty good. But this CMIT, we're going to do another page. We're going to do example 3B. Not the whole page, just one more. And this one is writing 0.18. So 0.18 repeating, we want to write as a fraction. Okay, so again, we set it up equal to x. And this time, we need we need to move that decimal place. Now, if we only moved it one time, seeing as our pattern is 2 digits, we would move it into the middle of the pattern, and that's not enough. We need to move it the full length of the pattern. We need to move it 2 times. That means we need to multiply by 100. So you need to see the length of your pattern and move it that many digits.
That will be solid up in 4 minutes, and this not
4 minutes. Okay. So now that means we have 100x equals 18.18 repeating. And now I'm going to subtract these two. So 100x equals 18.18 repeating minus x equals 0.18 repeating. And when I do that, I get 99x equals 18. Divide both sides by 99, and you get x equals 18 over 99. All right. So in class, we will add success criteria to these examples so that you can ask questions and we can kind of write out some steps and criteria you can use to be successful on every problem. But you should come into class with these notes. So you coming into class with the vocabulary, some examples of the vocabulary, example 1, 2, 3A and B, and you're ready to go. All right.